Okay, so this is where we left off. Just to recap, how the brain processes information is encoding. You have 5 senses, and the senses job, the sensory system's job, I should say, is to grab all the data that's in the air. So the most complicated way to explain this is this chart. It's the same PowerPoint presentation, so if you want this chart, you can print it out. But all of your sensory information, well, all of it except for smell. Notice smell is not on there. So 4 of your 5 senses are taking in vibrations from the air. They're encoding them into pulses in your brain, and then your brain is immediately deciding if it is important enough to pay attention to. If it's not important enough to pay attention to, it gets forgotten. It's an encoding issue. So we gave the example, if you walk down the hallway, there's a whole bunch of people with clothes on. It doesn't mean just because you didn't notice or remember what color shirt they have on that they're not wearing a shirt. Your brain deemed that so mundane and unimportant that it just didn't even record it. It's called automatic processing. Now, once you pay attention to something, this is the effortful process part. And it's not like you have to cognitively think about, I want to pay attention to that guy's shirt. So I don't want to confuse you. It is somewhat automatic, but think about what catches the attention of the mind. A color that's drastically brighter than all the other colors. A sound that's louder than the other sounds. When you hear your name in a crowded room. So something that catches the selective attention of your brain has now become effortfully processed. But that doesn't mean it's a memory yet. It doesn't mean it's stored forever. It actually just becomes a short-term memory at that point. Short-term memories may only be in there for a few seconds. If I tell you a statistic, you might remember it until the end of class and that's it. But if you start thinking about it and practicing it, you might store it for a longer period of time. Longer. And that's the idea of working memory. You take something that's a short-term memory, which your brain is paying attention to, and as long as you're working with it and you're thinking about it and you're practicing it and you're rehearsing it, that's the psych word, rehearsal, then it's going to be in your brain. Until it's not. One of 2 things happens. You rehearse it enough to make it a long-term permanent memory. Meaning you don't have to think about it anymore. It's in there. Like song lyrics or your mom's name. All of your favorite things, whatever it is. You have lots of permanently stored long-term memories. And you can retrieve them at any time. But if you don't store a long-term memory, then it also gets thrown away. So I like this chart better because it's a little bit cleaner. It's not as accurate, it's not as detailed, but it's a little bit cleaner. So, like let's say we see somebody in a yellow shirt. Well, all the other shirts get thrown away. It's that instant encoding. A sensory memory is essentially the same thing as encoding. It's the vibrations that are in the air that your brain grabs and converts them, right, into a color or to a sight. Now, I like this right here because look at this rehearsal wheel. As long as something is a short-term memory and you continue to think about it, practice it, study it, like take this class for example. You're going to rehearse the material for the tests until May whatever when we take the AP exam. And it'll still be in your short-term memory for a while, but the longer you go without reading and studying psychology, especially things like vocab, eventually what's going to happen? It's going to fall out of there. You're going to forget it, right? It's going to become decayed over time. Storage decay. That's what happens to memories. If you don't use them, they dissipate. Because your brain, here's why. Your brain only has a limited amount of space in the short-term memory. So I'm going to teach you another vocab word, one day too late, and that's interference. So imagine the metaphor of a bowl. So if your short-term memory is a bowl and it can only hold so much liquid, then as you pour more liquid into that bowl, something has to happen. Something has to give. It's going to spill out. So that's what interference is. Interference is when new data that gets processed into the brain is interfering, right? I shouldn't say new data. I should say data that's being encoded into the brain is interfering. In other words, your short-term memory is very limited, and there's only so much stuff you can keep in the preconscious mind. So you guys are stressed out, you're thinking about a lot of stuff, you got a lot on your brain, you're trying to juggle all these classes, you're trying to learn new concepts in your sport, maybe you're trying to pick up an instrument, maybe you've got a new job, and you're just getting stressed out, and you can't juggle and balance all of the new information in your brain. That's valid, that's true. That's called interference. So interference only happens in the short-term memory. Okay, that's important to understand. You'll never have to repeat that on a test, but it's an important concept for you to understand. Only short-term memories can be interfered with. Long-term memories they're untouchable. They are stored somewhere else in your brain. Right? That's why amnesia is important to put into two categories. If you have retroactive amnesia, it didn't damage the part of your brain that forms the memories. It damaged the memories themselves. It got rid of long-term memories stored in your brain. And it's actually pretty physically, biologically simple to understand why. Let's say that, this is not true, but just for the sake of visualization, let's say that like everything you've learned, your schema for math is like right here. Right? Let's say it's right here, and you're like occipital lobe. Just for visualization, it's right here. Well, if you get a tumor right there, and they can surgically like pulverize it or take it out, then all of that tissue that was there is no longer accessible. It's dead, it's gone, it's been cut out. So it's possible to actually physically remove memories from your brain. Bless you. That's retroactive amnesia though. Some kind of damage to the brain, or maybe even dementia, Alzheimer's, has started to break down the actual neurons. So that's an important thing to remember. What is a long-term memory? It's an actual neurological pathway that grows together. See, your brain is made up of neurons, and neurons are just small little cells that make up a nerve. One nerve is a bunch of neurons, and they're cabled together. This like fatty tissue called myelin. And myelin is what brings the nutrients. It also insulates, right? If you guys have seen like the extension cords, probably the orange extension cords that your parents have in the garage, well, if it gets like cut or frayed, or you run over it with a lawnmower and now all the wires are exposed, well, that affects the current. You have to re-insulate the wire, so you can take that black electrical tape and you re-insulate it. Well, that's how your brain works also. Myelin is this tissue that insulates a current in your brain. And the reason why that's important is this. There's a part of your brain that does nothing but reach out. In fact, the best way to remember it, when we get to that chapter in the next chapter, is that it's the Latin word for tree, like as in branches, dendra. So the dendrites of a neuron actually grow like a tree, and they reach out like an antenna so that they can capture any molecules that are going between neurons. So I know that's hard to visualize, but the reason why I'm explaining that is the way that long-term memories work is that you have actual growth of the dendrites of neurons, which creates a permanent pathway forever. In other words, it's not a working memory anymore. You don't have to rehearse it at all to remember it. It's stored in there forever. And you know that. There are things that you cannot unlearn. There's no amount of conditioning and behaviorism that will teach you or unteach you how to walk. That is so implicit in your brain that there's no undoing it now. It's so automatic that it's actually being processed in the movement part of your brain. It takes no conscious effort for you to walk. Now, a little baby that walks for the first time and they look like orangutans, right? That takes tons of conscious effort for them. They're actually having to think about what to do with their feet. And if you're thinking about walking, you're not thinking about anything else. You guys are advanced humans. You can walk and do something else at the same time. You've arrived. Now, but imagine if you tried to play a guitar and you didn't know how to play the guitar. Well, it takes so much conscious effort to figure out how to physically play the guitar. There's no cognitive space left to sing while you're playing the guitar. But some people have played the guitar for so long, it has become an implicit part of their brainstem, the cerebellum, that they don't have to think about playing the guitar. They're just automatically, implicitly doing it. So that frees up their conscious mind to think about things like song lyrics and stuff like that. So that's the whole practice until something becomes a habit. We're moving it from the conscious part of our brain to the unconscious part of our brain. It's actually going from the preconscious to the reptile part of the brain. implicit versus explicit memories. We'll explain that in just a second. So this is a process. Most of what I'm telling you requires rehearsal. I've rehearsed it so many times that most of this is long-term storage for me. It's not because I'm intelligent. It's because I've taught it a lot. So that I can take the summer off and lay around on the beach and do nothing productive and then walk back in here in August and open the book up and start teaching it again. But when I first started teaching this, it required a lot of rehearsal. I had to juggle between the vocab like you guys do, and it was a struggle. And who suffered were my students because they needed me to be an expert on this, and I wasn't. It takes practice. But now, I've done it so much that it's in there. It is a pathway in my brain. So I probably seem smart sometimes, but that's just because maybe I'm dumb, because I've studied the same boring stuff so much that I can't forget it or unlearn it. Right? They're actual pathways in my brain. So that's how long-term memories work. Now, we just explained to you the process of the circuitry of your brain. What's known as LTP is actually a reference to a biological process. Think about potentiation. The root word of potentiation is what? Just take the suffix off of it. What is it? It's potential. The likelihood. This is the likelihood that neurons will actually fire the same information over again, over and over again. So if you learn something enough, it actually potentially will be a permanent pathway in your brain forever. LTP is the biological explanation for long-term memory storage. That's all it is. It's the biological explanation for how your brain recalls information without having to really process it. It doesn't have to encode it. Now, we already talked about flashbulb memories and hormones and the limbic system of the brain and how the more emotional an event is, the more likely you are to store it. It's probably evolutionary development so that you don't die, right? When you keep doing the same thing over and over again because it was dangerous. You fell off of a cliff, and so you're like, well, I'm going to climb up again and see if it's different this time, right? And that's why you always see these Instagram memes of the definition of insanity is doing the same thing without getting different results. Well, that's true. And some animals don't possess the ability to learn from experience. That's problematic, because they're probably going to die a very preventable death, right? You just said it right there. That's why flashbulb memories exist. If something emotionally painful happens to you, and think about this is the essence of therapy, ladies and gentlemen. If you get so emotionally scarred in your first ever romantic encounter, that's going to have an effect on you in the future. Why? Flashbulb memories. Just to bring it home a little bit, right? PTSD. And it's no different than any other kind of PTSD. And why does your brain do that? Because Freud was wrong. Freud thought your brain would protect you from your painful experiences by blocking them out. In reality, your brain constantly reminds you of that garbage, hopefully so that you what? Don't do it again. But Freud was right about something, and that's daddy issues, right? Or mommy issues. And some people have daddy issues, and they mistake attention for love. And so instead of doing the smart thing and not chasing after those women who are bad for them or men who are bad for them, they just keep going after the same people, and their life falls apart. And they go, I don't know what's wrong with all the people that I date. It's you. You're 100% the common denominator here. You have a horrible taste and significant. That might be the case. And there's a good time and a good way to broach that subject if you're being a good friend, right? You can watch The Toxic Relationship for some pointers if you want to watch that video. But the point is the reason why we store emotional baggage is the same reason why we store physically painful baggage. It's a flashbulb memory. And the idea is that, that was painful. Really think about that. Let's not do that again. So some memories are in the emotional, hormonal part of the brain. Now, we just talked about implicit and explicit. I'm going to show it to you on a chart. And if for visual people, it's going to make a lot more sense. But you have to remember, right? There's two types of memories, basically. There are implicit memories and there are explicit memories. And the reason why that's important to know is because of the parts of the brain that we're dealing with here. You already know the part of the limbic system in your brain, the mammal brain that you share with dogs and dolphins, that forms long-term memories, begins with an H. What is it called? It's the hippocampus. The hippocampus's job, hippocampi, there are two of them, their job is to take experiences and to hold them in your brain. Now, unless you have an eidetic memory, then it takes practice. If you had a flashbulb memory, right, a photographic memory as we call it, every single experience that happens to you, no matter how mundane, becomes a flashbulb memory and you can't forget it. So think about that as the reason why it's important to forget stuff. It's important for your brain to discriminate what's important and what's not and automatically flush it out. Right? It may not be important in the grand scheme of your day by the time you get to sixth period for you to remember what color shirt I'm wearing. Especially not if something traumatic happens in the middle of the day. You're not going to remember much of anything that happened before. Right? I remember 9/11. I have no recollection of conversations I had on that day in my classes or what my teacher said to me because I was emotionally triggered. I was there, floating through my day. But the point is that when something emotional happens, that takes your brain's attention. And so the mundane stuff, the explicit stuff, that becomes a little less, that goes to the back burner, right? So your brain can only store what it's effortfully paying attention to, and usually it takes practice, it takes rehearsal. The only time your brain automatically stores a hippocampus memory is when it's extremely emotional. And it can be a good emotion.
Would it be possible to have such a traumatic event happen to you, like emotionally, they just stop creating memories?
Well, Freud says yes. And some psychoanalytic psychologists who study things like multiple personality disorder, they would say yes, but it wouldn't be that you stopped creating memories because the hippocampus still works. It might be that you're so psychologically traumatized that your brain creates alternative realities. You could develop delusions, in other words, right? So the hippocampus works unless you physically damage it. But you do have something that's known as a dissociative state, right? So dissociation is when your brain checks out and stops paying attention to stimuli around it. And now your brain stem still might be making you do stuff. So you walk around, right? Like you sleepwalk somewhere and you go break into a store and steal something and you come back and you have no recollection of it. That's known as a fugue state, right? It's action without brain consciousness. So that's dissociation. So dissociation is a very real thing. The brain can, out of a desire to protect you, we'll say, in a Freudian way, do essentially what you're saying. But the hippocampus does not stop functioning from a biological standpoint. Yes?
Can you force yourself to disassociate?
I mean, you might be able to convince yourself enough, for a placebo effect, but probably not. But again, perception is reality. So what you perceive is true. Michaela.
I feel like when they go through traumatic experience, they often dissociate after that. Is it triggers that?
Well, that's usually the essence of trauma. So the reason why you don't remember significant events, let's say it's just like a concussion, like an emotional concussion. Well, the reason why you don't have any memories of your concussion is because you lost consciousness while those events were happening. So your brain's actually not encoding that. Well, so what you're asking is actually very important for the test. We can't store anything that never gets encoded. So I guess this might help answer his question a little bit more too. So what you're talking about is, if I have an emotionally traumatic event, I may be so busy processing chemical, hormonal emotions that I'm not consciously thinking about what's happening around me. And so it's not like my eyes don't work, it's that the brain is just throwing away all the sight data. So I don't want to confuse you, but to answer your question in a way that will help you on the test, what would happen in an emotionally traumatic event would be that your brain would just automatically process everything that was not related to the event, right? So think fight or flight. If someone attacks you, or even if you perceive that they are, if you're walking to Panera Bread across the street and you think somebody's coming after you, it doesn't matter how real it is. Your emotions kick in, you get sympathetic nervous arousal, you get adrenaline, you get cortisol, and your brain's in flee mode, right? Or it's in fight mode. Well, 17 cars could drive past you that you have no memory of because it's just not important information. The brain is focusing all its effortful attention on the emotional part of the brain. So yes, that's a very real thing. And it doesn't mean that your brain recorded the memory and deleted it like a video on your phone. It means that the brain never recorded it, right? So if you guys like that analogy, just think of your brain's memory system like your phone. Well, if you push record, in theory, your brain is recording that. And we know that's not exactly how it works because it's connectionism. It's a combination of things. And that's why Loftus showed us that you can manipulate memories. But from a metaphor standpoint, I like that because if you have it on camera mode, but you never push record, your brain's not storing any of that. The camera's still working, the lens is still on, but it's not keeping any of it. It's just letting it all get thrown away. Can they be distorted? Yes. Can they be destroyed? Is that what you asked? Oh, very easily. But it depends on a lot of things. It depends on, I'll put it to you this way. There's a limit to Loftus's theory. What she found is that you can distort minor details in a major emotional event. So like somebody who gets mugged may forget what color shirt the person was wearing. That doesn't mean that they made up the whole event. You know what I mean? Like the details of the event might be real. Exactly. And they're not going to mistake a gun for a knife, right? Especially if they were like actually physically contacted with it. So there is a limit to it.
So would that mean that brainwashing is not like really possible like you see in the movies?
Not like you see in the movies. It would take the reason why brainwashing can work is because it would take the creation of a delusion. So the difference between a delusion and a hallucination is simple. A hallucination is something that you see or hear that's not really there. It's actual sensory data. A delusion is you've become convinced of something. It's a belief in something, right? If you're a little kid and you believe that Santa Claus is coming and you're like terrified that he's going to break into your house, that's a delusion. It's a belief. But it doesn't matter because it's real to you, right? So brainwashing would be an example of slowly creating a delusion in people. And that doesn't always require evidence. It just requires convincing, right? So yes, it is possible to brainwash people, but probably only to a certain extent, maybe. Not to the way that they do it in movies, you know, like Clockwork Orange or something like
So
that.
it's more like changing political beliefs more than
Probably.
changing personality.
Yeah, exactly. All right, so this is the chart that I like. This is another chart. If you want to print this one out, you can print it out. This is the best way to compartment, and it's actually, ironically, a good example of a hierarchy. In this chapter, it talks about how your brain processes information. So just follow the irony here. This is a hierarchy of processing for the hierarchy of processing that your brain does. That's what it is. Basically, in your long-term memory storehouse, there are two types of memories: implicit memories and explicit memories. Let's explain the difference, because the word declarative and non-declarative means nothing to us. Declarative and non-declarative are simply a way to explain what type of information this is. Implicit, I would put unconscious. That's a good word for it. It requires no conscious attention. It's something that you don't even realize you have the capability to do. It would be almost impossible for you to explain it. So like if you're explaining to someone how to play golf, you can explicitly explain the rules of golf and maybe explicitly explain the mechanics of a swing, but you couldn't implicitly explain how your body moves. And that's the difference. The difference is these are the unconscious things that your brain does without your awareness at all. So if we're saying you're walking down the street studying your vocab, what is the implicit task in that scenario? It's the walking part. It's real simple. People overcomplicate it. What is the conscious part? What is the explicit task in that scenario? The studying of vocab. So that's the way you differentiate these. It's real simple. If it requires me to use my brain to think about it, it's explicit. If it doesn't, and it's automatic and it's unconscious, it's implicit. And in fact, things that start out as explicit can become implicit with time. Like I said about babies walking, it takes a lot of conscious effort for them to think about walking until it becomes an implicit thing that they just take for granted. Yes?
So, I know when you said personality earlier, I know it changes grades. Can it like drastically change like
Yeah.
a nurturing?
So yeah, absolutely it can. And it can change even without physical trauma in the brain. It can change from emotional trauma. Like if you become scarred enough by your best friend since second grade, that might emotionally traumatize you into not being a nurturing person anymore. But it's just like anything else. It's like chemicals that you put into your brain, alcohol, marijuana, anything. Your brain is susceptible now because it's still figuring out homeostasis. It's still developing. It's still figuring out your chemistry. In fact, as you're rounding out puberty and becoming like a full-grown human, your brain is balancing your chemicals all the time. That's why you're sometimes an emotional mess and sometimes you're the emotional rock. It just depends on what your chemicals are doing. So emotions are chemicals. So if somebody emotionally hurts you enough, that can create a flashbulb memory, and in essence, it could scar you. It could change your personality. But you can also physically damage the brain and change your personality. Hopefully. If you get into a car accident or have a bad enough concussion to the frontal part of your brain, it can change your personality. In fact, I'm aware of a former athlete that had such a bad concussion it changed the color of one of their eyes. What? But they were young, 14. I think they were freshmen. I mean, it's a very early critical developmental stage, right? So, like, just to give you an example, somebody asked me last year during the season, well, okay, so you're a football coach. Would you allow your little kids to play football? And I said, if you're concerned about little kids and their brain development is valid, but little kids are not going to get concussions playing football because they run really slow and they stand 1.5 feet from the ground and they fall down like bowling pins. My biggest concern for letting a 5-year-old play football would be damaging their growing ligaments. A high school kid, I would have major concerns because you have physically tuned bodies running really, really fast, and you have car collisions happening on a regular basis in a still developing brain. So if you're concerned about CTE, it's not so much the 5-year-old brains. Even though they're way more vulnerable, they don't experience the violence. But at the high school level, you have underdeveloped brains, you have collisions, and yeah, that's problematic, right? So it's every parent's choice. But the shaming of the kids that are playing football when they're 5, I'm like, watch it. It's like watching turtles race each other. It's horrendous. Little tiny weebles that are like their helmets are touching their shoulders, and it's horrible, right? I know, they're all like, I don't know which leg to kick with, and they all run into a circle. And then you start looking at the statistics, and soccer in high school has the highest rate of concussions. Cheerleading has the second highest rate of concussions, right? So, and by a lot, it's not even close, right? So, you just have to weigh those odds. So, inside of the explicit domain, again, these are things that you consciously have to focus on. It requires frontal lobe attention. You have 2 types of explicit memories. So here's a good example of semantics. If you just try to memorize the words of this chart, it's not going to be helpful. So there's a basic level of knowledge that you just have to create right now. So you just have to kind of like lock in and try to comprehend it, and then you'll be good. If it requires conscious attention, right? So think E for explicit, E for effortful. I have to effortfully pay attention to it. Then those are in 2 different categories, and these are actually pretty easy. You have the episodic memories of your life, and you have the semantic information. So think like Netflix. You're watching The Office. This is season 17, episode 4, the one with all the masks at school, right? It's an episode in a long series of episodes that is your life. So if you get a test question that asks you about an event, it's an episodic memory. Episode. It is one increment, one event in a sequence of events. That time at your 10th birthday party, that's an episodic memory. It's an episode in your life. Like the capital of Iceland, that's semantic information. That's not an episode of your life. You're not going to remember the time that you learned the capital of Iceland, unless it's really traumatic. If you like get up there and fall off the stage and have a concussion or something, like maybe you do, right? I have an ironic story from college about both of these. So there was a girl that was in one of my college classes, and she was struck by lightning walking to class. And she was so embarrassed. She came to. She consciously woke up in this walkway, and people are standing over her worried about her. She had no recollection of it, so she ran to class. And then she started having headaches, and she went to the clinic, and somebody was in there, and they're like, oh, yeah, you're that girl that got struck by lightning. So ironically, that was such a horrendous event in her life. She remembers the event because it was embarrassing, but ironically, she doesn't remember any of the crap that she learned in class because she was so emotionally embarrassed. So sometimes episodes can prevent you from learning the non-important emotional stuff, the semantic stuff. That's what PTSD is. Yes. That's what PTSD is. So if you're a combat veteran, you don't remember the events of an attack you were involved in, you remember the minute details. You remember the sounds, the smells, the number of people that were around you, and that's kind of the perspective that shows maybe Freud wasn't right. Your brain doesn't protect you from semantic information. In that event, it actually keeps it, right? When Elie Wiesel wrote the book Night, are you familiar with the book Night? He's a Holocaust survivor. His original manuscript was 900 pages long. And his publisher was like, we can't publish that. But he remembered everything about being at Auschwitz.